member here in Urban Studies and Planning and Director of the Center for Transportation Studies. I'd like to welcome you to this seminar, a weekly seminar that we co-organize with my colleagues Rob Bertini, Chris Monsier, and John Glebe. Welcome. Today we have with us Professor Starr McMullen, who is a professor in both the departments of Economics and Agricultural and Resource Economics at Oregon State University. She's going to be talking about some research that she's been doing on the vehicle mile fee proposal in Oregon. And then I'm going to remind everyone, when you ask questions, to use the microphone in front of you. Hopefully it's working. Keep the red light lit if it lights. If it doesn't light, still press it down just in case it works. So thanks.
Okay, thank you, Jennifer. This the title's a little bit different than it is on the website. That's partially because until Monday I didn't realize that I was your program for this week. And the website title's it was a title I suggested last fall when I said I would give a presentation in the spring. This is the title of a project that I'm doing with Professor Lei Zhang down at OSU. He's in civil engineering, and Kyle Nakahara is a master's student in economics. And what we are doing is we're trying to look at some of the political policy and socioeconomic impacts of the proposed vehicle mile tax. So what I would like to do is do a little background on why we're doing this why we're even interested in this sort of thing in the first place, and then give you some very, very preliminary results. We are developing a much more complicated model that incorporates all sorts of demand feedback effects to further evaluate the model. So just keep in mind this is all very preliminary at this point. There we go. Basically, for those of you who are familiar with Oregon highway finance and highway finance in the U.S. in general, what we find is the highways are running out, and basically the existing financing mechanisms we have aren't really enough to get enough revenue even to maintain our existing highway system. And these are figures from a study that was done by Cambridge Systematics, where they estimated that just maintaining our current highway and transit systems require $222 billion in 2005, and just to maintain the system by 2015 would be $295 billion. And the bottom line is that as of 2005, the revenues that we had to do these things were falling short of our needs even in 2005. And this is without any improvements to the system. This is just maintaining the existing highway systems as they are. So it's recognized as a big problem both at the state level and also, of course, at the federal level as well. There's a whole bunch of reasons why this is happening. I put as the first one, let's skip the first one for a moment. Basically, if you look at number 2, this has been going on for a long time. That basically the costs involved in maintaining and constructing highways have risen over time. You're talking about steel costs, concrete costs, all these materials have gone up quite a bit. And the other thing is that our highway systems, in particular national highway systems, were built for a predicted traffic flows that were much lighter than what actually came to pass. So that basically the highways are running out, are wearing out faster than was anticipated. So both of those things have created needs that for maintaining and constructing highways. In Oregon, you know, we have an Oregon state fuel tax of 24 cents a gallon. That hasn't changed. I put in the last 15 years, Jim Whitty would probably know exactly which was the year that the Oregon 24 cent per gallon fuel tax was passed. But the thing is, when 1991. So 15 years was a very good guess on my part. And back then, that 24 cents a gallon was probably more than 10% of the cost of a gallon of fuel. And we all know now it's more than 20%. Now it's less than 10% of the cost of a gallon of fuel. And there's no adjustment upwards just for inflation and general increases in the price level. So there has been no increase in the tax. As we well know, there's no political support for increasing the fuel tax. So that as a source of revenue to fulfill our highway expenditure needs, that's not going to do it. At the same time, what we're experiencing, as you know, is that over time our cars, our automobiles, light vehicles to which this highway tax, fuel tax applies, have become more fuel efficient. So they need to buy less gallons of fuel, and therefore, for the same amount of miles being driven on the road, which is what determines the damage to the road, is how many miles cars drive on the road. For the same number of miles to the road, we're collecting less in taxes than we were before because of the fact that cars are more fuel efficient. So basically, the fuel tax is no longer serving as an effective road user fee, and that's because of the fact, that's partially because of the fact that we've got more fuel efficient vehicles. It's also because of the fact that the roads are wearing out faster, we've got prices rising, et cetera. The legislature realized this and appointed the Road User Fee Task Force, which is known affectionately as Rough Tough. And this is the mandate that was given to the Rough Tough committee, was to develop a design for revenue collection for Oregon roads and highways that will replace the current system for revenue collection. And this is being proactive, trying to get a system that's going to work before the current system gets any worse in providing revenues. And before I start out here, I want you to be clear that I'm an economist, and what I'm talking about here is the concept of user fees. So what we're talking about is we're talking about people who use the road paying for the damage they do to the road for the services they're getting from that facility. So basically we're talking about these gasoline taxes, or I will be talking about vehicle mile tax, as a road user fee, as a way for people who use the road to pay their fair share of the costs of maintaining and constructing the roads. So basically, that's the first one there, is the basic economic principle, is that the user pays a price equal to the marginal cost of use. A pretty nice concept in economic theory, very, very difficult to implement in practice. But that's sort of the basic standard that we've got behind the concept of optimal user fees. The state of Oregon has always been very innovative when it comes to highway pricing. Okay? Actually, in 1919, Oregon was the first state that imposed a highway use tax. Basically, it was a gas tax. Before that, I believe there was a work requirement. Everybody, I think it was every man, had to put in a certain amount of hours of work on the highway system in the state of Oregon. And after Oregon imposed the gas tax, other states quickly followed suit. And back then, you have to realize most automobiles, most vehicles on the roads were very similar in terms of fuel economy, et cetera. Okay, and the other thing in Oregon, which we're not going to be dealing with today, is the fact that we have a weight mile tax for heavy trucks. This is very innovative, and this weight mile tax in Oregon actually is more than just a truck weight and mile tax. It also has to do with ESAL weights, so that it much more approximates the damage that trucks are doing to the road. This only applies to heavy trucks that are over 26,000 pounds. Okay, so for today, what we're talking about are the vehicles that are basically below 6,000 pounds. We're not even talking about light commercial trucks that are under 26,000. We're talking about automobiles, pickup trucks, vans, SUVs, motorcycles, all the vehicles that use gas as the, mostly gas. Okay. So we have this gasoline tax, and until recently, this gas tax was a pretty good way of charging for road user fees, because until the last 25 or 30 years, most light vehicles, most automobiles, got pretty much the same gas mileage, so that basically they're all paying about the same per mile in terms of a user fee. Basically, and the fact is that miles driven are very closely related to road damage. Okay, so that way it may not have been perfect way of collecting a marginal cost user fee, but it did a pretty good job. Well, what's happened in the last 30 years or so is we've developed a much greater variance of different fuel efficiencies and fuel economies in vehicles, and therefore the gasoline tax has not become as accurate a reflection of the marginal cost those different vehicles are doing to the roads. And so what you have is different vehicles paying different costs per mile of traveling as a user fee. Okay, what the Rough Tough Task Force came up with as one possible and probably the preferred way of replacing the gasoline tax, the per mile gasoline tax, is using a vehicle mile tax. And this is something that's not just been discussed at the Oregon level. This is being discussed very actively in different states around the nation and at the national level. There's a TRB study that talks about alternatives to the gasoline tax, and the vehicle mile tax is something that comes up over and over again. The way that you could, to look at this, so the analysis you're going to see today, we're going to just sort of assume what we thought was, what I guess the Rough Tough had thought was the average fuel mileage for Oregon vehicles, about 20 miles per gallon, which is actually pretty close to the average fuel mileage of the fleet in 2001, which is when we have our data set for. And so you could take the 24-cent per mile tax and convert that into a vehicle mile tax of 1.2 cents per mile. And if all vehicles in the fleet got 20 miles per gallon, you charge them all 1.2 cents per mile, everybody would pay exactly the same amount and it would be revenue neutral. That's the idea. This is something that eventually we're going to play around with a little bit. We can look at different vehicle mile taxes to different vehicles, different locations, that sort of thing, but not today. This is something in the future. The first thing that people focused on when they sort of talked about a vehicle mile tax was all the mechanics of how are we going to collect this tax. You know, we're going to look at people's odometers. Are they going to give us real readings? Are they going to set it back? How are we going to do this? And what they did was the Oregon Department of Transportation contracted with a couple of researchers at Oregon State University, and they've developed some technologies for actually keeping track of the vehicle miles and enabling cars to actually take their vehicle mile count to the gas station and pay the vehicle mile tax instead of the gasoline tax at the gas station. There's been a pilot study up here in the Portland area. I believe it just ended in March, where they actually have had people running around using this technology to collect the gasoline, the vehicle mile tax. So that the technology is not really as much of a problem as it might have once been thought. And we've been developing it. And if you want to have a presentation by David Kim and David Porter, I'm not sure if you've had one here yet, but they have. Okay, so you've already seen that. It's really quite interesting. We're not going to talk about that today. What we're going to talk about is the fact that once the media got a hold of this idea and the articles on this technology, what we started seeing were articles that all of a sudden said, oh no, you're going to do this, it's going to be awful, it's going to have all these impacts on different groups in the economy. And I believe there was an article in Oregonian, and there was an article in the Los Angeles Times, the Seattle newspaper. Newspapers all over have made their comments about what they think of a vehicle mile tax replacing the gasoline tax. And what I've done here is I've tried to give you some of the comments that have been levied as criticisms of the vehicle mile tax, which basically have to do with some of these distributional or social economic effects that I'm interested in. One of the first things is people talk about vehicle mile tax hindering the adoption of more fuel-efficient vehicles because, of course, the fuel-efficient vehicles get like 50 miles a gallon, so they only pay a very small, and they only need, so that's 24 cents in taxes per 50 miles, and if you replace that with a 1.2 cent per mile, they'll be paying more in tax than they would if they just paid the gasoline tax. And on the other end of the spectrum, of course, there's the fact that the vehicles that get very low miles per gallon, okay, they will end up paying less per mile tax as far as under the vehicle mile tax system. Okay, and so there's questions about what it's going to do to the adoption of more fuel-efficient vehicles and then there's tied to that various kinds of environmental and energy concerns. I'm not going to deal with this I'm not going to deal with this much at all right now, partially because there's a whole literature on optimal vehicle emissions taxes. And if you look at the literature, Ken Small and Sarah West are economists who've written on this. And basically, if you read their articles, what they end up suggesting is that a vehicle mile tax is a better way to collect vehicle emissions or charge for vehicle emissions than just the gasoline tax. And that's simply because of the fact that a lot of the emissions, once again, are related to miles. So I'm not going to get into this. There's also all sorts of questions about various tax breaks for hybrid vehicles and all this stuff. Sarah West also does an analysis of that and points out that if you're worried about the regressivity or who's getting the advantage of these, it's usually people in higher income groups who take advantage of the tax breaks to buy the hybrid vehicles. So in that sense, those rebates are regressive. What I'm going to be focusing on are, and it's all hard to get data on who buys hybrids and stuff. We don't have a good data set on that yet, but we will eventually, hopefully. The second one is the thing that I'm going to focus on most today, and that I think is probably the one that we have the most data available on, although the data is not as perfect as we would like. There's the argument that a vehicle mile tax would be regressive and basically hurt those relative in low-income groups relative to those in higher income groups. And I'll define regressive in just a minute. Another concern is that the vehicle mile tax might discriminate against people in rural areas who have to travel farther distances, don't have as many public transit options and things like that as well. And then this is another thing that's been tied in with this too. I consider this a whole other topic, this whole idea of congestion pricing. That's a whole other issue here. The vehicle mile technology would allow us to charge a congestion toll, time of day, change the vehicle mile tax rate by time of day. Yes, it does give you a technology that allows you to do that. But right now, I'm just concerned about the user fee aspects of it. Okay, and usually in the articles you see in the paper, they mix all these things up together, and some of them, a vehicle mile tax is good for some, may not be for others. And what we wanted to do was get some idea of what the relative sizes of these effects are. Past studies haven't dealt necessarily with too much with the vehicle mile tax and the socioeconomic impacts. But basically, they have dealt a little bit with some of the political problems with trying to change taxes, and in particular, vehicle mile tax. And Sorensen and Taylor, basically, they say if you just focus first on just a simple sort of road user vehicle mile tax, and don't deal with the congestion pricing part, which is a whole other controversial issue, that probably will be politically more acceptable to start with. So they suggest first implementing a vehicle mile tax, then later considering something like a congestion tax. Okay, so what I'm going to do today is I'm going to start out looking a little bit at some of the distributional impacts of these different taxes. And the reason I've said the impact of the gas tax or fuel tax versus vehicle mile tax is because people say vehicle mile tax, everybody's going to pay it, so it's going to be bad for the poor, it's going to be good for the rich, it's going to have these distributional effects. Well, you have to realize we're not just putting the vehicle mile tax on, we already have a gasoline tax. And the gasoline tax has its own distributional effects, which are generally acknowledged to be pretty regressive. Okay, and so what I'm going to do is look at the change. What would happen to the distributional effects if you change tax systems? We're going to use some preliminary data on Oregon, and I'll tell you a little bit about where we're going in the future. Just starting out with looking at the gasoline tax, some of this is background stuff. A lot of you who are interested in economics literature, I can give you more references. I'm trying to cut it down today. Basically, the argument is, well, you put the gasoline tax on it, who actually ends up paying? Do the wholesalers pay or do the retailers pay? Well, the bottom line is, or do the consumers pay? The bottom line is, in a state like Oregon, you change the tax, it's going to get pretty much passed along to the consumer. So we're going to assume that throughout what we do here. This is my very simplistic definitions of regressive and progressive taxes for those of you who may need to have this refreshed a bit. Basically, a progressive tax, by definition, it takes a smaller percentage of income from those in lower income groups and a higher percentage of income from those in higher income groups. And a regressive tax goes the other way around. It takes a larger percentage of income from those in lower income groups. The conventional wisdom, and I've cited here some from Congressional Budget Office studies, suggests that the gasoline tax is somewhat regressive, which means it takes a greater percentage of income from those in lower income groups, less from those in higher income groups. And that's sort of conventional wisdom on sort of sales taxes in general. People in higher income groups spend, but they don't spend as great a proportion of their income. Okay, some other researchers here have found mixed results. Some find some progressivity over lower income groups. I put here that Sarah West, she includes zero income households, vehicle households, and I've got those results in my tables. But just if you think about it, if you don't include households that don't have vehicles, then you're going to have different results than if you include households that have zero vehicles. And what we find is usually the zero vehicle households are usually at the lower end of the income distribution. And so if those people don't spend anything, then it doesn't matter what you tax them, it's not going to have an effect on them. So it actually always makes it look less regressive if you include the zero income households, zero vehicle households, in your analysis. Okay. This I'm just putting in as a comment. What we usually do, and what I'm going to do today, is I'm going to say, what if everybody has the same cars they have, the same income they have, they drive the exact same miles they do now, but only thing that changes is the price, is the vehicle tax, is the tax that we're talking about. What's going to happen to, who's going to pay more, who's going to pay less? In the real world, we all know that when you have price changes, there's a demand response. So if some people face a higher price, they might drive less, or they might choose less vehicles and that sort of thing. And obviously, if you wait long enough and you can get these price responses, if you ignore demand responses, that makes the tax seem more aggressive because people are locked into their ways right now. If you let them have a while, they may adjust, get a more fuel-efficient car. They may do something, or they may drive less. They may use more transit. They may change their behavior patterns. Okay. So eventually, what we're going to be doing is estimating econometric models of demand that allow us to get some of these demand responses in. Okay. Okay. There's some questions about the income measure to use. Basically, in all the data sets that we have, there's always a problem with measuring income. And part of that's because the way the income measure is set up in the data set we use, it's all categorical. It's like people in $0 to $14,999 and people in the next group up. So all we have are really sort of a guess of the median income of the family. I already talked a little bit about zero income households and the fact that today I'm going to use the simple calculations, assuming you have the existing vehicles and miles and the existing taxes. And in the future, we're going to be looking at, our goal is in the next few months to be looking at some more models that give us some demand responses. In doing something like this, there's a lot of data requirements, obviously. We need mileage data, both for households. What we'd really like to have eventually is for each household that has more than one vehicle, we'd like to have the mileage that each vehicle drives so that we can see when these prices change, how people substitute between vehicles. Like if they have one vehicle that's real fuel efficient and one that's not, does that change their patterns? So we basically would, and the data set we're using right now does have that available. We'd like to have a cost per mile, which is fuel cost, and then we have the gasoline tax, basically the amount they spend on gas. We'd like to have a measure of miles per gallon so we know whether we're talking about fuel-efficient vehicles or not. We need some income data. To deal with the question of location, we need some urban-rural indicator. We'd like to know how many vehicles they have. We want to know some household demographics. And those are vehicle characteristics on the bottom. Oops. Uh-oh, how do you go back? There. Right now what we're using is data from the National Household Travel Survey. I think that's what NHTS stands for. And what we have is a 2001 data set. For Oregon, one of the big drawbacks is there's only 407 households in that data set. But it does have a lot of the data that we would like to have. There's some question as to how good our urban-rural indicator is, because it's a census definition indicator. We can get into that some other time. As I said, there's a categorical income variable instead of actual income, fairly small sample size, and I'd like to have a better urban-rural indicator. These are sort of the averages that we get from the data set that we have for Oregon, which shows an overall average fuel efficiency in the fleet. And this isn't the whole Oregon fleet. This is just the fleet of the vehicles for the households that we have data on that from that household survey in Oregon. But it's not too far off that 20 miles per gallon average that they were using for getting the 1.2 cent per mile VMT. It's true that people in rural areas seem to drive more than people in urban areas. That's sort of conventional wisdom, and that is showing up in this data set. We show that the rural population seems to have a longer commute distance to work than the urban, things you would expect. These are car types and stuff, and this isn't a great diagram, but I tried to get the table to translate into this, and it kept dropping it. But basically, in rural areas, there's more SUVs, which are pickups, the green, and the blue is cars, station wagons. This is urban areas, so you can see there's less pickups. I mean, sort of what you would expect. And then in the urban areas, you've got the beige area, which is SUVs. So, and this is the comparison, just to see that how well this sample of Oregon households from the NHTS actually approximates what's going on in Oregon. We took the census data from Oregon and looked at the percentage of households that fell into each of these income groups. And this is from the census data. This is from the data set that we're using here. And so when we looked at that, we said, well, it doesn't look like it looks like it's fairly representative of the different income distribution of households in Oregon. Not perfect, but not too bad. In other words, the NHTS probably undersamples the people over 100,000. Okay. So what I'm going to do is just show you our simple first calculations. I'm using the 2001 data. And I've done two things. One is I used the gas price that was the average gas price paid in that sample in 2001, which was $1.46 a gallon, as recently as 2001. And you know what the papers are talking about today, these gas prices over $3 a gallon. So in the first example so I've got two examples in this table, which is going to be really sort of complicated. The first one is assuming what I call net gasoline price of $1.22. So what I've done is taken the 24 cent a gallon gasoline tax out. And then in one case, I'll show you the incidence if I put the gasoline tax in. And then, since I know the MPG for each household, each of the vehicles in the household, I've calculated an average MPG for the household. And then I've given them, and I know how many miles they've driven, so I've given them a vehicle mile tax. So I've looked at the total expenditures on gas and road user fee under the two scenarios. First with a retail gas price of $1.46, and then we simulated it again, assuming everything's the same except for the fact that gas prices were $2.60, which I thought at the time was sort of reasonable, but it's higher now. Yeah. Yeah.
Try it.
Mm-hmm.
Why only a 14 cents gas tax on the 260 price?
I guess it must have been $2.70. It should be 24 cents. And we used a net price of It should be it's 24 cents more. Sorry about that. I put that slide in this morning, and I guess my arithmetic skills were not as good in the morning as they should have been. Sorry about that. Okay, so, and just this is based upon 122 net cap price, and you can basically see we just did a little exercise. These are the different fuel efficiencies: 21 miles per gallon, 23, etc. This shows you, the blue line shows you what they're paying per mile in the gas tax, and the red line shows you the VMT tax. So you can see for lower fuel economies, the gas tax pays slightly more per mile. This includes both the gas price and the road user fee. And one of the things you might notice is that total line has got both the gas price and the tax in there. There is a difference, but it's really a small relative to the whole cost of gasoline per gallon. And this is with $1.22 per gallon. If you would double that price, you can find that it may make a change here and there, but they're really tiny changes. This is sort of hard. This is the incidence table, which might not be as easy to see. This is assuming a gas tax of $1.22, and I would say this excludes the zero vehicle households. So that's sort of basically we're sort of ignoring the people who really don't have any cars anyway. And just the fact that they're not affected by this doesn't necessarily mean it's good, because it may just mean they can't afford a car, and there's some other issues there that we're not going to get into. But this basically is assuming this is the gas tax incidence, and you can see that this definitely seems regressive. In other words, 6% of income, this is the lowest income class, which corresponds, I'm sorry this is by number instead of, but it's like 0 to 14,999 income, and then each of these are progressively higher income groups, and then the highest income groups pays 1.8% of their income as taxes. Now, if you change then to the vehicle mile tax, you can see what that does there. It changes, this is percentage of their income, has a little bit, increases the regressivity here a little bit here, and then these groups sort of decrease. This one here and this one decreases. Very small impact, but there is some impact. So you could say, well, okay, you change from gasoline tax to the vehicle mile tax. That's going to increase regressivity. Well, it does to some extent a little bit. It's a very small amount. But then what I want you to do is compare that to what happens when the price of gasoline doubles, which is pretty much what happened between now and 2001. That's the upper part of the table. So you say, assume a net gas cost of $2.40. Well, you can see the same pattern in the relative regressivity of the gas tax versus the vehicle mile tax. But notice, the whole thing's gotten a lot more regressive. And that's because of the fact that the major part of what people pay at the gas pump is for gas, and the price of gas has gone up. So that really what's really driven the biggest increase in regressivity is the increase in gasoline prices. It wouldn't be, that's really, it's what happens when you change from one tax structure to the other is absolutely negligible. And when you say, well, what are the behavioral responses going to be? Well, if doubling the gas price is not making people run out in droves and buy hybrids and real fuel-efficient cars right now, do you think that changing the kind of road user fee by that little amount is going to make any difference? I would venture not. But these are preliminary results, so we may find other things as we go along. And one other thing I'd like you to note is, in each of these cases, I've put all vehicles. That includes those zero vehicle households. Yes, that makes the gasoline tax look less regressive than it does in this case here. But you can see a large part of that is because of the fact that people in lower income groups are the ones who have the zero vehicles. So they don't have any incidence. So when you look at, but that doesn't necessarily mean they're any better off. Okay, so that's what we have on the income distribution effect so far. Okay, another aspect of this that we've sort of looked at is what happens to people in urban areas versus rural areas. And a lot of the concern that's been raised so far has been the people in urban areas. They drive farther distances, they drive more miles. So what's going to happen to them? Well, if you also remember, if you look at the other slide, they also have more pickup trucks, which probably get lower gas mileage. These are what we find from just the samples, rural and urban samples. And you can see that we have a much smaller sample of rural households than urban households. But in general, if you impose the 1.2 cent per mile, and this is, I believe this is at the 240. I'd have to go double check which gas price this was. But basically, in the rural areas, these are annual average household expenditures on gasoline plus the gasoline tax or the fuel tax or the vehicle mile tax. You can see that the change would reduce expenditures by the rural families by $13, increase urban family expenditures by $2. Now, the other thing you might think of when you look at this is you might say, well, that means that, gee, it's not the rural people who are worse off now, it's the urban people. We're upset about that. Well, think about it. We don't have any demand responses in here yet. And if you're talking about demand responses, you're talking about prices going up. Who have more alternative options in traveling? The urban people or the rural people? Well, usually the people in the urban areas have other transit modes they have available to them to travel, maybe more carpooling or whatever. So if these results hold as we expand our analysis, I would argue that does look like urban households are paying a little bit more, $2.04 a year per household. So figure out how much that is per day, per person, etc. And I don't know, maybe that probably isn't enough to drive everybody into public transit. But I mean, so maybe you really want to change it differently. So, okay. Well, where's my other? I have another slide. Oh, okay. Well, I've had one other slide, but I guess it didn't make it into my final copy here. The other slide I had was this is where we are now, was a quote from the New York Times. No, I'm sorry, the Wall Street Journal on, I think it was May 5th. And they were quoting a professor from Princeton University who was talking about imposing carbon emissions caps. And he said, even if the carbon emissions caps increased the price of gasoline by 30 cents a gallon, that probably wasn't enough to make people run out and buy hybrid vehicles. And my comment is, I don't think this is anything like a 30 cent per mile increase in gasoline cost. And what we're talking about here is maintaining the road system. And that's something that has to be done eventually anyway. So those are my preliminary results here. What we're doing next, and we're in the process of trying out some preliminary models here, is when we say direct demand estimation, we're estimating equations, basically regressions, where we're estimating the demand for vehicle miles. And when I say simultaneous equations models, we're doing that simultaneously with the demand for vehicle miles, but also looking at the number of vehicles people choose and what fuel economies they choose. So we're trying to get some of these things about, how people trade off between different fuel economy vehicles within a household. And this last model is one we really like to get to, which is more of a longer run model, but it's probably quite a ways down the road. Each of the models has more data requirements, and so in order to test these models, we're going to try to expand our data set a little bit. We're doing some cluster analysis, trying to figure out which are similar states to Oregon that we could use data from the NHTS data set to try to get better estimates, et cetera. So, but this is where we are right now. And I'm happy to try to field some questions if you have any. Yes? So, you guys can duke it out here. I think the fellow in the back had his arm up first.
You mentioned the carbon accounting for carbon. I'm wondering what kind of, we've got Gore out with, his movies starting with carbon accounting. What real moves are being made in this country to actually, or especially in transportation, to account for some of the carbon emissions that are being obviously being emitted? I mean, we've got vehicle gas tax at this point. A vehicle mile tax seems like a viable option in response to that. But really what I'm seeing is carbon is a big problem also. Are there any serious moves being made in that realm to account for that?
I know they've redone the CAFE standards, and that's sort of an aim towards there, but this is not that's not my real field of expertise. I believe this article that was in the Wall Street Journal on the 5th of May, that's what they were talking about, but they were talking about carbon caps not just for transportation, they were talking about it all industry-wide. And the point that was made in the article was that putting them on just for transportation was likely to have very little impact on transportation, on the emissions through that. These other studies, the West and the Small and these, they are basically economists who are trying to recommend various ways to deal with various kinds of emissions, which of course us economists, we always want to say, well, just charge the right price, put that on. But when we say that, the politicians and the public say, no, we don't want taxes. We got that for free before. We don't want to pay for it. And that's where, I defer to Tony and other people in the room who might have more knowledge about the.
I didn't want to put you on the spot.
Oh, no.
It's just you mentioned it, and it's something that piques my interest.
Well, I was mentioning because these things all sort of get put together because people say, well, let's put a tax on miles to deal with the carbon emissions, and then they also say, well, then we'll do it for the user fees, and then we want to deal with. We want to try to promote efficient vehicles. Then we want to try to reduce fuel dependency. So what you have are, they're trying to use this one thing, which is a vehicle mile tax, to deal with all these different issues. And sometimes the optimal tax for one of them is not the optimal tax for the other. What you'd like to have is something that does them all. But as far as the ODOT is concerned, for instance, they need to collect revenues to cover the roads. And in Oregon, I'd like to say this is one of the states where the money that goes into the highway fund either goes for roads or transit. It doesn't go into the general fund and get distributed and used for, to take, I don't know, to pay for prisons or something. I mean, it is a dedicated fund, and so it's, but it really is running short. Yeah. You were next, yeah.
I got two questions. The first is, you were mentioning that there are some preliminary studies going on about like how well it works, the technology works, and stuff like that. Kind of from what you've said, I gathered that you'd have to actually go and put the technology on every car. Has any of that been dealt with? Because I can see people being like, well, I'm just not going to put it on my car, and therefore I'm going to get out of not only paying the 24% tax, but then.
Oh no, the way that it was originally proposed has been to have a dual system for a while. And so
you could be getting paid twice, or you could be getting dinged twice?
No. You go, as a matter of fact, these pilot studies, they've actually had the cars go up to the gas station, and they get charged the price without the gasoline tax, and then they pay the vehicle mile tax. But if you don't have the mechanism, then you would pay the 24% gallon per gallon tax. And this is a big thing. This is why you're probably not going to see this technology being used for, 20, 25 years. But if everybody in the nation sort of is going this way, then automobile manufacturers will eventually start putting the mechanisms in the vehicles, and eventually there'll be a conversion. But I don't see it happening, next year. No.
My other question is with this new form of taxing, what type of increase in revenue would you actually see? Because here it's basically saying that, to me, it sounds like it's about even. So where does the increase come from funding?
This is even right now. The way that we've dealt with it, the 1.2 cent, that's about revenue neutral. And I think that the first goal is to keep the revenues from continuing to drop. Is basically, sort of to maintain the revenues. And then there's the question of, what are the different fees you want to charge? And that becomes, once again, it's just like any other, do you change it with inflation? What do you change it with? But you're right, it starts out right now being proposed as revenue neutral. Yeah, someone, yeah.
Oh, well, she asked my question. I was going to ask what you do about the declining value of your receipts because of inflation, and you just covered that.
Yeah. And obviously, once you have the technology in place, and this technology is really good. I mean, in a sense, it can tell you when you cross state lines. It can tell you when you cross districts. It can tell you when you're in different areas. And that's one of the reasons why some places, for instance, are real conducive to charging like an area pricing scheme or something. If you're in an island or something, there's always a bridge to go over. In the Portland area, there's not, but they can give you the technology to do that, yeah?
How expensive is the technology and who pays for that?
Well, obviously, if it's put into the vehicles, I'd have to do a study on the incidence to see how much of it's being absorbed by the automobile manufacturers and how much is being passed on to consumers. But, I think it's the total is about $250. I'm not exactly sure. It's something on each vehicle, yeah. So, yeah, that's a valid
And then it has to be
question.
maintained?
Well, I assume if it's defective, you'd have a hard time getting gas because, when you went to the gas station, that's where you would be doing your payment. So it's not like something where you keep track of your record for the whole year. And I think that was one of the original objections is, well, people can just report their mileage every year, but who's to say that it's really the mileage, and then you don't have the constant flow of revenues coming in as far as the state's concerned. Yeah.
A couple questions. One is, it doesn't work either. Am I hearing that there's a gap between 26,000-pound vehicles and 6,000-pound vehicles, that they aren't having any particular heavyweight vehicle tax? Or
They pay the 24-cent
they
gallon
pay the 24 cents
on
because
diesel or gas.
it seems that there is somewhere in there that you're seeing a greater impact on road use due to the weight of the vehicle long before you get to 26,000
I believe
pounds.
if you're talking about not light vehicles, and when I say light vehicles, they're talking about basically passenger vehicles. When you're talking about commercial trucks and stuff that are under 26,000 pounds, I believe the figure's about 1.8% of the vehicle miles in Oregon are attributable to that class of vehicle. So, you're right. This is something that, as far as I'm concerned, I don't want to say they should pay the vehicle mile, the weight mile tax, because I really make myself enemies here. But the thing is, those trucks don't do nearly as much damage as the trucks in those classes above them, because there's sort of an exponential increase in the amount of damage that's done once you get above the 26, especially if you get into the 80,000 pound range.
And with this idea of having a vehicle mile tax, or with the road mile usage, is there any thought of allocating the funds per mile of road? As you talk again about urban versus rural, the rural people may be traveling more miles, but are their roads getting as much attention and a fair share of the dollars?
The urban?
The rural.
The rural. I'm sorry, could you please, are you saying that because there's not as many miles driven there, is that what you're saying?
It may not be as many miles overall, but for an individual, it tends to be more miles, and are they getting a fair allocation of the money if people are being charged per road mile?
Presumably, it would be the same, if we just went to this revenue neutral scheme, it's the same pool of funds, and I would assume that the state would be allocating funds to the different projects in a similar way that they do today. Now, whether you consider that fair or not, that's, I think, another question. Yeah.
We have a question from someone watching on the web. Sir, if you know of any research that's been done sort of comparing this concept to just using road tolls and sort of maybe the difference, maybe if you could talk maybe just conceptually about what the difference would be in terms of what you're charging for. And he particularly is asking, would it be more effective to tax certain routes which are highly used, or is it more effective just to do the vehicle mile tax?
So you're talking about putting a toll on every road?
Not necessarily.
Right. Well, historically, there's been tolls that have been placed on things like bridges, to pay for that facility. Sometimes those tolls get lifted, and sometimes they don't. And I usually see tolls discussed more when we're talking about congested areas, which presumably would be the use that you're talking about. For instance, the I-15 down in the San Diego area, where they actually have a toll there that varies with time of day, so it deals with congestion pricing as well. So that's usually what you get into when you get into the congestion pricing, or an alternative toll like the is it the SR91 in California as well. I mean, I guess conceivably you could try to charge people a toll every time they got on every road, but it seems to me that then we're talking about a lot of administrative costs.
No, I think he's just wondering about the difference tolls on some roads. And I guess one different, I mean, it's sort of a different concept. I mean, a toll on a road is usually levied just to pay for that facility, or at least that corridor, whereas a gas tax, user fee, mileage fee is to pay for the entire system in theory. So, I mean, that's one sort of big difference, I would say, between the two.
Yeah. I guess if you're there's different kinds of toll systems too. You know, you could what I tend to think of is the congestion pricing toll. So you have different time of day tolls. But I think this is you're right. The user fee is just for the basic road system, which really has nothing to do with time of day exactly. That's more of the capacity question. Yeah.
Starr, you presented most of the results in terms of the incidence of the total cost of gas plus taxes. But in doing incidence analysis, we usually look at the taxes separately. I mean, I can see the argument for doing it that way, but did you also look at just the tax incidence, and do you get a different conclusion from that?
It's just so small compared to people's incomes. You know, you're talking about 0.000002 of their income, and so I haven't put a table together like that. But I mean, I would expect the results would be similar. I haven't done that, no. Or I think we did in the beginning, but weren't sure that was, you know, that isn't the way that people usually do the tax incidence on the gas tax that I've seen. I think, yeah. Oh boy.
Well, I think it somewhat relates, and I'm wondering. So you had the the $2 more and the $13 or so less. Was there a pretty small range, because that was an average for the average household, and I would imagine the main differences have to do with how fuel efficient the household's vehicles are. Any sense of the range of values? I mean, did it get very high for anyone? Was any household paying a lot more?
I don't have any figures on that right now. I'm sure there's a couple. I don't really know, but so you're thinking of the distribution of households. How many pay more, and how many pay less?
Is everyone, all the urban households, is it, between like minus $5 and plus $15? I mean, is it?
I don't really know. We just took the average there, and that's something we could look at. We could also look at it by different income groups as well. That's a good idea. Yeah, in the back.
Can you talk a little bit about this National Highway survey with 407 households in Oregon? Is this in any way a scientific poll? Where do they find those people?
Where do they? Oh boy. It's done by.
Because if it's a scientifically random sample, then 400 is probably okay. Population study, but it would have to be a very good sample.
It's a national sample that's actually done, and then they have samples in each state. Actually, some states actually don't have, and then some states have paid to have extra households included in. So, for instance, in Wisconsin, there's 17,000 households in Wisconsin because they paid to have an addendum there. I believe it's a scientific study. It's done by. I think it's the national. I have to take Federal Highways. Yes, I mean, I'd expect it's a random sample of some time. Part of the problem is we can't tell exactly where these households are, because what they did was they surveyed each household, and then they classified where they were based on the census definition. So I mean, it's hard for us to tell exactly where they are. So the big concern we had was more the rural-urban, because sometimes those definitions are not really what they should be, especially in terms of what's relevant for rural and urban Oregon. Often we'll really sometimes talking about east-west Oregon sometimes as opposed to rural-urban sometimes. We like to look at it other ways. But yeah, that is a concern, especially when we're doing the statistical analysis, which involves the regression and that stuff. That's why we're trying to expand the sample. Yeah? Did you? Someone back there? Yeah.
Yeah. Sorry. What was my? Could you play? No. Okay. The question was, when you're doing this kind of in your econometric analysis, and some of which I understand you haven't gotten to.
No, I haven't gotten
yet.
to the econometric. I haven't presented any econometrics yet. No. This is all just sort of static comparison stuff.
So, one of the concerns when you're doing sort of a qualitative choice analysis is that the subjects that you're studying haven't necessarily been exposed to the range of, say, fuel prices that you might want to forecast to. In other words, the survey done in whatever year it was, 2004, the prices were lower. Okay. So have you considered doing any sort of stated choice, stated preference work, or have you? Are there any plans?
You said qualitative choice. I understand.
Yeah. Are there any plans to do any sort of longitudinal analysis?
Well, it would be nice to do a longitudinal analysis if we had a data set. And I believe the more recently updated NHTS may be available soon, but I'm not exactly sure of the release time. So ideally, yes, you would want to be doing longitudinal, especially if you're interested in the impacts on vehicle choice, because vehicle choice is going to take a while. People, even if the prices change, they're not going to change their vehicles for a while because it's a large capital expense. So that would be ideal. As far as stated preference, that's a whole other can of worms, and I would say that's another study. I mean, I think that probably is something which would be appropriate to look at vehicle choice, in particular hybrid choice. And then you do get into the question of whether people are used to these different price variables and stuff like that. We were just doing a cross section, so, and right now, yeah, each of the households has a different. We have a different amount that they spend on fuel and a different fuel cost for them each. But it's within the spectrum of whatever the prices were in 2001. So it's not like everybody's got 1.46 cents. That was the average. So when we do the econometrics, we will have some variance, but it won't be the variance that will include doubling the fuel price and stuff like that.
Taking into account household budget functions in any way?
Could you be a little more specific?
Well, yes. Assuming that gasoline is one component of what a household spends its income on, what data do you have, or do you have data that would allow you to sort of, I guess, get a more precise estimate of what their total consumption is of all goods and services versus...
As opposed to their income? Yes. That's one of the slides I skipped over. The reason I skipped over it is because the answer is there is data available on people's consumption. There's a consumer expenditure survey, which Sarah West uses, but there's some big problems with that in the sense that they only have total household miles. They don't have miles for individual vehicles. They also do not have vehicle miles per gallon, which of course we need to do this because we have to know, we have to be able to figure out how it changes their cost. So you have to know what the fuel efficiency is of their vehicles. And that is in the NHTS data set. So those are the two things that have made us not choose the consumer expenditure survey. There is an argument that actually the income, and as I mentioned, there's problems with the income. It's just the categorical. And obviously there's a bunch of research that suggests what you should really be using is consumption expenditures, not income, because consumption expenditures more if you ascribe to the life cycle theory of consumption and savings, that would better represent their lifetime income. So I mean, there's theoretical reasons for using that consumption expenditure. The problem is the other problems with that data set have made it so that we haven't been able to figure out a way to use it. Yes.
What are the biggest challenges that you see in its implementation? And how far along do you think this will actually be implemented?
What are the biggest problems?
There has been talk about, invasion of privacy and stuff, so.
Yeah, and I know there is that talk. I also know I am not on the technical side here. I just want to make sure that you realize that. And I think Kim and David Porter would be much more familiar with all the issues there. But by the same token, I know that increasingly people have things that enable people to track them down. I mean, your cell phone, people can figure out where you are. So I know that this is an issue, but I think it's become less of one. I think that the problems with the road systems and stuff is going to get severe enough that I think not only is congestion pricing inevitable, some sort of congestion pricing, but something like this. It may not be in the next 5 years or 10 years, but I think eventually down the line, there's got to be something. Something's got to give, and they've got to. We have to figure out ways to maintain our transportation system, and not just passengers, either freight. Everything travels on the roadways, especially intercity. Yeah.
You were talking about sort of decoupling the VMT fee from a congestion fee and from emissions fee. But I know that in Southern California they've looked at these together because they see them really as so interlinked. They're so much part of the same problem, and they don't want to make bad infrastructure investments by addressing one or the other piecemeal. And since people kind of know that, you have it up on the screen and saying, well, why don't we just do VMT fee now and then do congestion pricing later? Is it a little cynical maybe, and maybe wouldn't the better path be to just put it all out on the table at the same time and trust the American people to be, all right, I'm going to be crazily optimistic, and that they could understand the relationship of those things, and to really try to implement a full system that will take care of things for a long time, address demand in a reasonable way, and deal with emissions.
If you think, if that politically can get through, I think that would be the optimal way to go, obviously. The reason I sort of said I'm not talking about it today is because I really think that the very first level of concern is just sort of having enough funds in those collected to cover the highway expenses to maintain the roads. Now, when you get into congestion pricing and stuff there, you're also getting into questions about what's the optimal capacity of the road, and do you want to have, do you need more roadways? Do you need what you need to do? And it seems that historically, for the last 25 years anyway, in my professional career here, we've talked a lot about congestion pricing, and unless you're in, except for a couple cases in Southern California and maybe in the Texas, Katy area, a few places, it just politically we've not been able to really implement it. I'm not sure, and once again, I'm not the techie guy here, I'm not sure what additional infrastructure you really need. If you have the infrastructure to collect these VMT fees, all you have to do is say, okay, if you can sell the congestion fee, or you can sell a corridor fee, you just say, well, we'll collect it from the people who've driven the miles on there. We'll charge them, 2.4 cents instead of 1.2 cents a mile. So I think that I think that adding these fees to deal with emissions or whatever, it's very easy to implement it. It's just a matter of charging different fees for different places or whatever. But I think that if you don't have the system in place, it's going to be hard to do. So, I was just sort of saying it might be politically easier just to do it as a road user fee system if people realize they won't have the roads there, or they won't be drivable. Sort of like what happened to the railroads. Look at the rail lines. You have all these derailments. You have the trains going 10 miles an hour. Because the railroad companies were not able to maintain the right of way. Yeah.
Sorry, I'm just not really familiar with congestion prices. How do people pay tolls in congested areas?
Well, ideally they would. It would basically give you the optimal. Hopefully, it would give you an optimal traffic flow at different times of the day. So, for instance, in Southern California, on the certain part of the roadway, people have little transponders or whatever, and when they enter the roadway, At a certain time, it sort of says you're going to be paying $6, or you're going to be paying $9, or you're going to be paying $3 for using the roadway. So it depends upon, it's real-time pricing, so it depends upon what the traffic is on the roadway. If it looks like it's getting congested, they'll increase the price of traveling there, and that affects, and people can choose whether they're going there on that, or they just stay on the road, which is basically a parking lot, at rush hour. So I mean, so there are some places where they have congestion pricing or toll. See, to me, that's sort of a toll road, but that's really congestion pricing, sort of. I guess they call it high occupancy and toll lanes. Yeah. Although I'm not sure that one, actually buses go on that one, but I'm not sure that actually high occupancy vehicles actually go on that anymore. Yeah. They do, for free?
They might charge by now. They might.
Yeah, I
put
think
a
they
lower-
charge for them.
But it seems like natural, you still get to split the.
Right.
They got the built-in
Right.
natural incentive.
Right, yeah. I believe I went to a conference here about 15 years ago where they had some pilot project money to do a congestion pricing project up here in Portland. And it was just a whole bunch of people, and they just basically said, they basically didn't want it here. And they did try it in other places, but.
Any additional questions? Before we thank our speaker, I'll put in a plug for next week. We have Peter Stouffer, a professor from University of Sydney, joining us all the way from Australia. He's going to be talking about using a GPS panel to evaluate travel behavior changes, so it should be quite interesting. Thank you very much.